Okay, problem number 1. For solving this problem, we want to use Gauss idea. Gauss idea is what, for example, in my previous video, I solved problem with that idea. When you want to calculate this, so if you write it in reverse order, 100 plus 99 plus 1, then if we add up these two things together, each one will be 101. And exactly here we want to use, so it is what Gauss idea. We want to use exactly these things. So here, as you can see, k can be from negative 2021, negative 2020, up to, for example, negative 3, negative 2, negative 1, 0, 1, 2, 3 to positive 2021. Now, I consider this one with this one and say, okay, for example, it is a, it is negative a. 1 over 10 to the power of a plus 1 plus the first one, last one, like here, 100, write it in reverse order. For example, it is this one s. If you write it in reverse order, then it will be 1 over 10a plus 1 plus 1 over 10 negative a plus 1. If we add up these two terms, let's see what we have. It will be 10a plus 1, and I can write 10. Let's write like this. I wanted to change it to 1 over 10a, but it's okay. So it will be 10 to the power of negative a plus 1 plus 10 to the power of a plus 1. And it will be what? 10 to the power of negative a plus 10 to the power of a plus 2. And here 10a, 10 negative a will be 1 plus 10a plus 10 negative a plus 1. 1 times 1. And we see numerator and denominators are equal, so it will be 1. So if we write it like this one, and also for 0 you can do the same things. So 2s equals what? Like here we said 2s is 100 times 101. So how many terms do we have? 21 numbers here, 21 numbers here, 40, 42 plus 1, 40, 43, and it will be what? 40, 43 times each column is 1. So we have this number of numbers, each of them, if you add, if you write in reverse order, each of them will be 1. So here, if you write s in reverse order, all these fractions, then this plus this is 1 here. We've proved this plus this. All of them will be 1. So now 2s is 40, 43. The problem says find integer part of 2s. So because it is integer, so integer part of 2s equal to 40, 43. For my previous students, I solved problems with Gauss idea with exactly similar way. For SMO, also for Amy America, if you had any question or want to learn completely, want to solve different problems of this important idea, also in IMO we can use international. Feel free to send message to my WhatsApp number in the description and comments. Problem number 2. Exactly 2 days before the exam, I released a video. In that video, I said, okay, some problems, especially junior, senior, but this time also sometimes open section, you should find example, you should write some small example to find the pattern. And this problem is easy, but with that idea you can solve also hard problems, especially also in round 2. So let's solve this problem. Also this idea is useful in AMC for America and BMO for British. So let's solve. All the positive integers 1, 2, 3, 4 and so on are grouped in the following way. G1 is 1, 2. So let me write. Okay, G1 is 1, 2, G3 is 3, 4, 5, 6, G3 is 7 to 14. It says what? The set Gn contains the next 2 to the power of n positive integers. So we have 2 numbers here, we have 4 numbers here, we have 8 numbers here. If you consider G4, it starts from 15, and look here, it is 8. 7 plus 8 minus 1 is 14. So here we have how many? We have 16 elements. 15 plus 16 minus 1. 31, it is 30. If we write, for example, G5, it will be what? it will be 31 to 31. How many elements do we have? 32. 31 plus 32, 63 minus 1, 62. So I can write until G8, but let me tell you the pattern. This number, if you consider the last number of each of them, it is what? 16 minus 2, 2 to the power of 4 minus 2. It is 2 to the power of 5 minus 2. It is 2 to the power of 6 minus 2. This one is 2 cubed minus 2. This one is 2 squared minus 2. The problem says find until G8, and you can easily prove that all of them have this condition. For example, it was for round 2 or other problems you should write. We can easily prove with induction. So here it is what? For 5 it is 2 to the power of 6 minus 2. So for 8 is what? 2 to the power of 9. Look, it is 5, it is 6 power. It is 4, G4, 2 to the power of 5. So for G8 it will be 2 to the power of 9 minus 2. And now, because it says add up all the numbers, we should add from 1, 2, 3, 4, all the elements up to what? 2 to the power of 9 minus 2. 2 to the power of 9 minus 2. 2 to the power of 9 is 512. It will be 510. So if we use the formula, 510 times 511 over 2. You can divide both numerator and denominator by 2. It will be 260. 255. Let me correct it. 255. And now if we multiply, it is S. It will be 130 if we calculate 305. And the problem says find integer part of S over 100. So it will be integer part of this number, and it will be what? 1303. Okay, I released the full solutions of open section, junior section. I'm releasing open section, so keep in touch to have next solutions, and please don't forget to subscribe for having next videos. Thanks for watching and for your support. Okay, problem number 3. For solving this problem, as I said in my previous video, there are 5 important identities you should memorize in any exam. AMC, AME for America, also in your school, you need these 5 identities. Let me write. Okay, I've written 4 of them. And the 5th one, it takes time because telescoping rule I should explain, and we want to focus on this problem. I only wrote 4 of them. You can have 1 or 2 more. Are important. Memorize these 4 things, and some other identities are that are less important than this. So if you had any question about the other identities, as I said, feel free to send message to my WhatsApp number in the description and comments. Okay, so let's solve this. So a sequence of 100 positive integers, okay? Positive integers, x1 to x100 are such that we have this. Find the largest possible value of this. Okay, so let's consider this A. So we can say what? A, x1 squared, x1 is at least 1. All of them are at least 1. So A is at least what? X1 is at least 1 because there are positive integers, 1 squared. X2 is at least 1, so 2x2 is at least 2. So it is at least 2 squared. Similarly, 3 squared, 4 squared. Now you can understand. Which of these 4 identities here is useful? Pause the video and think. 2, number 2. So here, if I replace, it will be 100, n is 100. 101. 2 times 10, 100 plus 1, 201 over 6. And if we simplify, we can simplify 2 by here, 550, and 3 by here, 6, 7. And it will be what? It will be 50 if you multiply this times 67. And if you multiply this number, it will be 38350. It is exactly this number. So we understand if all of them, all x1 to x100 equal 1, then we reach this number. If at least one of them is greater than 1, then the left side will be greater than 33, 83, 50. So all of them should be 1, only one case. So x1 plus x2 plus x3, 2x100 equal to 100. So I will release the other videos. Please don't forget to subscribe and turn on notification to have next videos. Thanks to watch my video and for your support. Problem number 4. Okay, in this figure, if we see, we have circle, parabola, and one important thing is to drawing diagram approximately to understand the problems as well. So let's read the problem. Let A and B be two real numbers satisfying A less than B, and such that for each real number M satisfying A less than M less than B, the circle x squared plus y minus m squared equal to 25 meets the parabola 4y equal x squared at 4 distinct points in the Cartesian plane. Let S be the maximum possible value of B minus A. Find floor of 4S. So also for SMO 2021, in I can say most of the years, also in AME and AMC problems. One important thing in 2022, 2021, one important thing is to drawing diagram approximately to understand the problem says what. Okay, if we draw y equal 4y x squared, divide both sides by 4y equal x squared over 4, and the circle center is 0, the coordinate m, 0, m here, and as you can see we have 4 distinct roots. Now for also you can imagine, but drawing is a little better for also hard problems of AME for America and also BMO for UK. I released some problems of them. If you draw like this, then it helps you to solve the problem. Okay, so let's solve this one. We know the first equation. If I write these two equations, okay, we have these two equations. If I one other thing, replacement. Replacement is so much important, and you can solve also some problems that are hard, especially for more for round 2, but also in function problem it's useful. So if I replace y with x squared over 4 in first equation, it will be x squared over 4 minus m squared equal to 25. If I expand, I have x squared plus this squared x to the power of 4 over 16 plus m squared minus 2 times m times this, which will be minus m x squared over 2 equal to 25. Now I multiply both sides by 16, then I have 16x squared plus x to the power of 4 plus 16m squared minus 8mx squared. 16 times this, 16 is 4 times 4, 4 times this 100, so it will be 400. So I can write x to the power of 4 plus x squared, 16, this one, and this one, minus 8m plus 16m squared, and take 400 to left hand side, negative 400 equal to 0. Okay, now we want to find 4 x's. So if I consider x squared equals t, then we have a quadratic function in terms of t. Plus t 16 minus 8m plus 16t minus 400. So here we want to have 4 intersections, so we should have 4 answers for x, and we know they are different. So if we want to find 4 different answers for x, then what should we have? X will be here, we can find t1, t2, and x will be plus minus root t1 and plus minus root t2. Then we can say x has 4 solutions. In what case t1 and t2 should be positive. So here the roots should be positive. So we have a quadratic function, the roots should be positive. So the first condition is d should be positive to have 2 different roots. The next one, sum of the roots should be positive, and also product of roots should be positive, and it is equivalent to have 2 positive roots. Why? Because discriminant is greater than 0, we have 2 different real roots. Product is positive, so t1, t2 have same sign because some of them is positive, so both of them are positive. So we apply these 3 conditions. 16, quadratic function also in AME problems are so much useful. Working with roots, sum of roots, and especially for degree 3, it will change to Vieta's formula, and for some other degrees, Newton's sum that are useful. So discriminant is b squared 16 minus 8m squared b squared minus 4ac minus 4 16t minus 400 should be greater than 0. T1 plus T2 sum will be what? Negative b over a. It has roots. So let me write. Okay, here. Alpha plus beta is negative b over a. You should memorize these. Rules are useful in many exams. So T1 plus T2 is negative b over a. Negative b here is what? Negative of that. 8m minus 16 over a. A is 1, should be positive. And T1, T2 is c over a. Here it will be 16t. Let me, oh, sorry. Here I should correct this one. It was m squared, not x squared. So we should place m squared here. So d is b squared minus 4ac. So I should change this t to m squared and 8m. Okay, t1, t2 is c over a. It will be 16m squared minus 400 greater than 0. Now, these two conditions are so much easy. Then 8m is greater if you add 16 to both sides, 16, and if you divide both sides by 8, m greater than 2. Here 16m squared is greater than 400. If we divide both sides by 16, it will be 425. And by m greater than 2, m is positive, so m is greater than 5. So by these two conditions, we conclude m is greater than 5. Now we should consider discriminants. So let me write it again. Okay, I've written this condition again here. Now we can multiply this. Okay, if we divide both sides by 64, then here if you consider inside, you should divide by 8. It will be 2 minus m squared. And 64 here divide by 4, and here divide by 16. It will be m squared minus 25 greater than 0. So here you say m squared plus 4 minus 4m minus m squared plus 25 greater than 0. And if we simplify this will be cancelled. Negative 4m, take it to right side. It will be positive 4m. 4 plus 25, 29. So here we conclude m is less than 29 over 4. So what we conclude, m is from here greater than 5, less than 29 over 4. If we see the problem again, it says m is between a and b, and b minus a, maximum possible of b minus a. So it is b, it is a, and okay, s is what? Maximum of b minus a, and find 4s. Integer part of 4s. So 4s is what? Is 4 times this b minus a, 29 over 4 minus 5. If we multiply 4, 29 minus 20, which will be 9. And because it is integer, so integer part of that is also integer. And it will be equal to exactly 9 itself. So the answer of this problem is 9. Okay, I will release next solution. Keep in touch for having next videos. Thanks for watching my videos and for your support. Don't forget, please, to subscribe and turn on notifications. Problem number 5. Let P be a point within a rectangle ABCD such that PA is 10, PB is 14, PD is 5, PC is what? So let's consider. Okay, if we consider this one is x, then we can say what? Here. For example, suppose it is m, it is m, it is n, it is n. And it is y, it is also, for example, w. So here if we write Pythagoras theorem, 10 squared equal to y squared plus n squared. If we write Pythagoras theorem here, then we can say 5 squared equal to y squared plus m squared. And if we subtract 10 squared minus 5 squared equal to n squared minus m squared. So similarly, if we do the same thing for these two triangles, n squared minus m squared equal to 14 squared minus x squared, it will be 100 minus 25 equal to 196 minus x squared. Here we have 75, so x squared equal to 196 minus this 6 minus 5, 19 minus 7, 2, and 1, so x equal to 11, and integer part of that equal to 11. It is similar to Carnot's theorem. We've solved problem with this idea. If you had any question about this, feel free to send message to my WhatsApp number in the description and comment. Problem number 6. In the diagram below, the rectangle ABCD has area 180 and both triangle ABE, this one, and ADF have area 60, 60. Here ADF 60, find the area of triangle AEF, this one. So if I consider, for example, this one X, it is Y, it is Z, it is W, so this one is Z plus W, this one is X plus Y, so the equation we have X times Z plus W over 2 is 60, so it will be 120, and here we can say W times X plus Y, for this triangle over 2 is 60, it will be 120, and because the area of rectangle is what, 180, so we understand X plus Y times Z plus W equal to what? Equal to 180. And now if we multiply these two things, we have on left side xw, z plus y w times x plus y is equal to this, so 180 equals 120 times 120. So if we simplify xw, if we divide both sides by 180, 120 times 120 over 180, it will be 0. If we divide by 6, it will be 3 here, 6 will be 2, 3 here, 40, so 2 times 40, 80. So we found also xw. Also here, we can write another things. We are writing all things that maybe are useful. We know this is 120, it is 120, so they are equal. So I can write xz plus w equal to yw plus w times x plus y, so xz plus xw equal to wx plus wy, xw we can cancel, and we conclude here xz equal to yw or w. Okay, here we can say if we consider this one, it will be what? It will be xz plus xw equal 120. We know xz equal xw equal 80. So here 80, so we conclude xz equal to 120 minus 80, 40. So we conclude here it will be 40. Okay, we want yz to find the area it is and then subtract. Because we want yz, if we expand this, xz, it will be 40 from here. xw will be what? Will be 80. yz equal to what? We want to find that. yw is what? Is 40 equal to 180. Okay, 40 plus 80, 120 plus 40, 160. So if we take 160 to right hand side, it will be 20. So yz is 20, yz over 2 is 10. Now we know the whole area is 180, 180 minus 60, 60, 120 plus 10, 130. It will be 50. So the answer of this problem and the area of this is 50. We have some similar rules, ideas in geometry. There are around 50 important formulas. If you want to know them, as I said before, feel free to send message to my WhatsApp number in the description and comments. Problem number 7, a tetrahedron in R cubed has one vertex at the origin, here O, and other vertices at the points A, B, C. These coordinates, if x is the height of the tetrahedron x, then from O to the plane ABC, find 5x squared. Okay, for solving this problem, at first I want to find the coordinate of equation of plane ABC, and after that I want to find the distance of O from ABC. So if I want to find ABC, at first I find BA. BA is what? This minus this 2, negative 2, negative 4. Then I try to find CA. It will be what? It will be 6 minus 2 is 3. minus 2 minus 6, and then BA cross product CA. It will be 12 minus this 8. For this one, it will be negative 12 plus 12. And the last one is what? For this one, negative 4 plus 6. Okay. It will be what? It will be 4, 0, 2. So we can say what? It is n dot. If you want to find the coordinate, you say this dot xyz equals 0. So 4x plus y times 0 plus 2z plus k equal to 0. So 4x plus 2z plus k equal to 0. Now if you replace one of them, for example, a 600, so it will be 24 plus 0 plus k equal to 0. So we find by replacement k equal to negative 4. So we found the coordinates of the plane. It will be 4x plus 2z minus 24 equal to 0. Now we want to find the distance of O. We say absolute value of this term. When you replace O here 0, 0, it will be absolute value of 24 root 4 squared plus 2 squared. It will be 24 over 16 plus 4 root 20, and it is x. The problem says what? Find 5x squared, floor of that. So 5x squared, floor of that, it will be 5 times 24 times 24 here, all over 20. If we divide, it will be 4. If we divide 6, 6 times 24 is 144. So the answer equal to 144. Problem number 8, let x and y be real numbers such that x minus 2 squared plus y minus 3 squared equal to 4. If s is the largest possible value of this, find s minus 17 squared is okay. Before, exactly 2 days before the exam, I released a video, and in that video I said Lagrange multiply, we want to use exactly that. G equal to x minus 2, the condition, take all things to one side, y minus 3 squared minus 4, f is x squared plus y squared, define L equal to f minus lambda g, it is equal x squared plus y squared minus lambda x minus 2 squared minus lambda y minus 3 squared plus 4 lambda. Now, if we differentiate from this in terms of x, it will be 2x minus 2 lambda x minus 2, and it equal to 0, and you can cancel these two. If we differentiate from y, it will be 2y minus 2 lambda y minus 3 equal to 0. Now we conclude, if we take lambda to one side, x over x minus 2, and here lambda, if you divide, it will be y over y minus 3. So we conclude x over x minus 2 equal to y over y minus 3. If we cross multiply, xy minus 3x equal to xy minus 2y, xy will be cancelled, and 3x equal to 2y. So we conclude y equal to 3x over 2. Now if I replace y with 3x over 2 in the main equation, then I have x minus 2 squared plus 3x over 2 minus 3 squared equal to 4. Now here I can say, okay, it is what? If I factor from 3, at first let me write, it can be 3x minus, if you use common denominator, over 2 here, 4 plus x minus 2 squared, and we can factor 3 over 2, and if you take it outside, it will be 9 over 4. If you factor from 3 over 2, it will be x minus 2 squared equal 4 plus x minus 2 squared. And now if you factor from x minus 2 squared, it will be 1 plus 9 over 4, which equal to 4. And here it is what? 4, 13. And if we multiply by 4 over 13, then we have 16 over 13. So x minus 2 equal to plus minus 4 over root 13. Now we know what? We know y is 3x over 2. So x equal to 2 plus minus 4, if you take negative 2 to right side, 4 over root 13. Now if we use here star, y equal what? 3 over 2 times this. It will be 3 plus minus over 2, 6 over root 13. The problem says what? find x squared plus y squared. It is what? The problem says the maximum of this largest possible, it is s. Find s minus 17 squared. Okay, if I want to find that s minus 17 squared integer part of that, so at first I should calculate these. The first one will be what? This one will be 4 plus this squared 16 over 13 plus or minus 2 times 2 4 this 16 over root 13, and the next one plus y squared, it will be 9 plus this one 36 over 13 plus minus 2 times this 36 over root 13, and it will be what? 4 plus 9 13, 16 plus 36 will be 52 over 13 will be 4, and plus minus it will be plus minus 16 plus 36 will be 52 over root 13. It is what? 17, so it is s. So s minus 17 squared will be what? Will be 52 over root 3 plus minus, because you take 17 to right side, squared. So it will be 52 times 52 over 13. If we divide, it will be 4, and it will be 100. Oh, sorry, 2 times this is 104. We multiply by 2, or let's correct it. 4 times is 8. 4 times 5, 20. So the answer is 208. So again, Lagrange multiply, and there are also some other ideas, are so much useful in SMO problems. And also before the exam, I released exactly the idea of this. We've solved Lagrange multiply, and I told you that you can use it in the following SMO. And if you saw that video before the exam, 2 days before exam, you could solve this problem easily. Problem number 9, let S be the maximum value of W cubed minus 3W subject to the condition that we have this. Find G of S. Okay, again, we use two important things also before the exam. I told them at first differentiation and drawing approximately this diagram. If I differentiate, it will be 3W squared minus 3, and we want to see it is equal to 0. Then 3W squared is 1, W equal to positive negative 1. So in W1 and W negative 1, different derivative is 0. So in 1 we have what? 1 minus 3, negative 2. In negative 1 we have what? 3 minus 1, 2. So it is 2 here. Negative 2 in these two values. We have this. Okay, and we know for large W it will be positive infinity. So for 0 it will be 0. So it passes through this. And it will be something like this, approximately. It's not important. Now it says W4 plus 9 is less than or equal to the 10W squared. If we take to left side, it is equivalent that it is less than or equal to 0. Consider W squared equal to T. Then T squared minus 10T plus 9 is less than or equal to 0. So T minus 1, T minus 9 is less than or equal to 0. So we conclude that the roots are 1 and 9. It is this function. It is less than or equal to 0. So between the roots. So T should be between 1 and 9. T is what? Is W squared is between 1 and 9. So absolute value of W is between 1 and 3. So W can be between 1 and 3 if positive, or if it is negative, less than equal 1, greater than equal negative 3. Now, the W from 1, 3, for example, 3 maybe, yes, it is here. From this part we can have. And W negative 3 to 1, if we place negative 3, it will be something like here to this part. And if we want to check that the maximum is this, we should place this number, check these two. If you consider negative 1, it will be 2. If you check 3, it will be 3 cubed minus 3 times 3. It will be 27 minus 9, which equal to 18. So the answer, it says GIF because it is integer. Floor of that is also 18. So the answer is 18. So drawing approximate diagram And also consider derivative, as I said before, exactly 2 days before the exam. Consider the derivatives Lagrange multiplier. It was useful in all parts, junior, senior, and open section. There are also some other ideas I will release in other videos. And if you had any question, feel free to send message to my WhatsApp number in the description and comments. Problem number 10 in the quadrilateral ABCD below, it is given that AB equal to BC equal to CD and ABC equal to 80 degree, okay? BCD equal to 160, this angle. It says ADC is X, so we can say, for example, it is Y, it is 160 minus Y. It says find the value of X because the whole term BCD is 160. We can write like this. We should find X. Okay, here we can say it is 80. It is an isosceles triangle. So 180 minus 80 is 100. So it should be 50. And this one should be 50. Let me erase if it's possible. No. Okay, so let me write 50 here. Equal to 50. And 160 minus 50 is 110. Okay, we can say we said 50, 110, 80. Okay, so here we say it is isosceles, this equal to this, 50 plus 110, 160. So 180 minus 160, 20 is left, so it will be 10. It will be 10, and this part will be 70, this part 10, and okay, 70 plus 50, 120, so it will be 60, and it will be 60. So if I call this one P and I use sign rule in PAB, then I will have what? Let me write this term as, for example, T. So T over sine 60 equal to AP over sine 70. And also in triangle PCD, if I use again sine rule, it is equal to T by assumption of the problem, T over sine 60 equal to PD over sine 110. If we divide, TT will be cancelled, sine 60 will be cancelled, sine 70 equals sine 110 because their sum is 180, so equal to AP over PD. So we conclude AP equal to PD. Now, because AP equal to PD, it is 60, it is 120. So in this triangle, 180 minus 120, 60 over 2, it is 30, 30. Also, we prove it is 10 because of isosceles triangle. So it will be 10 plus 30 equal to 40. So here we've used only sine rule. We didn't use any important formulas. But as I said before, there are around 50 important formulas in geometry that are useful from qualifying level up to IM. And also for round 2 problems, you can use them. Also, I released some round 2 problems of senior, junior, and open section. You can see I will use these things and the formulas that are important. Problem number 11, let ABC are B integers with AB plus C 49 and A plus BC is 50. Find the largest possible value of ABC. So here, look, we have integers, so we should pay attention. If we subtract this from this, so A plus BC minus AB minus C equal to 50 minus 49, which will be 1. So if subtract this minus this equal 50 minus 49. Now if we factor from A, it will be A 1 minus B. If we factor from C, B minus 1 equal to 1. Now if I factor from B minus 1, it will be C minus A equal to 1. So both of them are positive 1 or both of them are negative 1. If both of them are negative 1, B minus 1 is negative 1, so B is 0. So in this case, also we should check that is it good or not. But because if we consider this case, it will be better. So we don't need to check that does it satisfy or not. B minus 1 is positive 1. B equal to 2 because we want to find the largest possible value of ABC. Here 0. For the second one, we find a large positive number. So B is 2. C minus A is 1. Also, if you use this, for example, equation, A plus BC. A plus BC is 2C we have, because B is 2 in this case, is 50. Now, here if I add these two terms, then I have 3c equal to 51. And if you divide both sides by 3, it will be 17. And a is c. If you take a negative a to right side, positive a to left side, c is c minus 1 is a. So a is c minus 1, which is 16, and b is 2. So you see that it satisfies all of them if you replace. In this case, a, b, c will be what? A is 16, b is 2, and c is 17. If you multiply, it will be 544. Okay. Problem number 12, find the largest possible value of absolute value of a plus absolute value of b, where a and b are co-prime integers. A and b are integers which have no common factor larger than 1. It means this, such that a over b is the solution of the equation below. Okay, so also for previous problems, I told to my students one thing that is useful for solving this problem, raising to the power of 2. The second thing you should pay attention when you have, for example, squares of something, consider it as a. It is useful in AME, also in Hong Kong problems, also for 2022. You can use this. Okay, so a equal to root x plus 1. Now, if we raise both sides to the power of 2, a squared will be x plus 1 and x will be a squared minus 1. And if I replace here, it will be 4x, 4a squared minus 4 plus 5 minus 4a plus root x will be a squared minus 1 plus 2 minus 2a equal to 1. And if we simplify, it will be 4a squared minus 4a, 5 minus 4 plus 1 plus a squared minus 2a plus 2 minus 1 plus 1 equal to 1. And then we can conclude it is what? This term 2a minus 1 squared, and this term is what? A minus 1 squared. So we can say absolute value of 2a minus 1 plus absolute value of a minus 1 equal to 1. Again, as I said, when you want to solve these problems, also in AME, in AMC, you should do what? You should consider, draw it approximately. So the important points are what here? It is 0 when a equals to negative 1 over 2, and here for 1. So these 2 points are important, 1 over 2 and 1. So if a is greater than equal 1, then we have left side. We want to consider only left hand side, this part. It will be 2a minus 1 plus a minus 1, which will be 3a minus 2. If a is greater than equal 1 over 2, less than 1, it will be 2a minus 1 plus negative of this, 1 minus a will be a. And if we consider a less than 1 over 2, it will be 1 minus 2a plus 1 minus a equal 2 minus 3a. If I want to draw it, if I consider 1 over 2 here and 1 here, they have this point, and between them we have a. If I draw with pink, you should draw it approximately as I said. Here after that we have this around the we can say the gradient is 3. Before that the gradient is negative 3, and for example for 0 it will be what? 2. Okay, so it exactly carries here. So we want to see when it is equal to 1. So we have 2 points that is equal to 1. So a can be 1 or this one. The coefficient, the equation of this is 2 minus 3a. So 2 minus 3a equal to 1, this intersection. So 2 minus 1 is 1, take it to right side, 3a, so a is 1 over 3. So we find 1 and 1 over 3 for a. Now we can say what? A was what? A was, x was a squared minus 1. X, a squared minus 1. So for 1, for the case that a is 1, it will be 0. For the case that a is 1 over 3, 1 over 3 squared minus 1, which equal to 1 over 9 minus 1. And 9, 1 minus 8 minus 9, it will be minus 8 over 9. The problem says consider absolute value of numerator plus denominator. For this one, it will be 8 plus 9, 17. For this one, that a is 1, a squared minus 1, 0. So if you want to consider, it will be 0 over 1, and this one will be greater, absolute value of negative 8 plus absolute value of 9. So the answer is 17. Problem number 13, let S be the set of real solutions x, y, z of the following system of equations. These three equations for each x, y, z in S. Define m of x, y, z equals 2000, open bracket, absolute value of x plus absolute value of y plus absolute value of z, close bracket, determine the maximum value of this for all of these things. Okay. So this or this is not good, but if we consider reciprocal of each equation, for example, the first one is 1 plus 4x squared over 4x squared is 1 over y, and now that's better because we can write it for 1 over 4x squared plus 1 over y, because we have 1 over 1 over x. So we consider, for example, x1 is 1 over x1, y1 is 1 over y1, and okay, so because if we write 1 over 2x squared plus 1 equals 1 over y, because to get rid of this over 2, we can consider a 1 over 2x1, 1 over 2y, 2x, 2y, and z equal to 1 over 2z1, 1 over 2z. Now, here from the first equation, we say, okay, this x1 squared plus 1 equal to 1 over y is 2y1. And similarly for the second one, if we write y1 squared plus 1 is equal to 2z1, and z1 squared plus 1 equal to 2x1. If we add all these three equations and take all things to left hand side, it will be x1 squared plus 1 minus 2x1 plus y1 squared. Look here, this one, this one, this one. Also, you can write for y1 squared plus 1 minus 2y1, this one, this one, this one. And the last three terms, z1 squared plus 1 minus 2z1 equal to 0. And we can say x1 minus 1 squared plus y1 minus 1 squared plus z1 minus 1 squared equal to 0. So we can say x1 equal to y1 equal to z1 equal to 1. So here we know x is what? X is 1 over 2x1 here. And because there are 1, so we can say x equal to y equal to z equal to 1 over 2. Now here, if we add all of them, 1 over 2 here plus 1 over 2 plus 1 over 2 will be 3 over 2. And if we multiply, they will be cancelled. 2, so it will be 3000. Okay, problem number 14. Assume that t is a positive solution to the equation this. Determine this. Okay, so as you can see, if you write t like here again, it will be root, we continue, 1 plus the 1 plus until here. So if we write it again and again, we can conclude t is congruent to 1 plus root 1 plus root 1 to square root of 1 infinity. Now here we can say it is also t. If you raise to the power of 2, it will be t squared equal to 1 plus t. So here we can say, okay, we know t squared is what? Now we want to, this idea also is useful in AME problem I saw in American Math Olympiad. So t cubed is what? You say multiply both sides by t plus t squared. Again, replace t squared plus by 1 plus t. We try to decrease the powers. It will be 2t plus 1. And t to the power of 4, we multiply both sides by t. It will be 2t squared plus t. 2t squared will be 2 times this plus 2t plus t. It will be 2 plus 3t. Now, if you replace t to the power of 4, t to the power of 4 equal 2 plus 3t minus t cubed is 2t plus 1 minus t plus 10. Okay, so it will be what? Negative 2t, negative t, and 3t, they will be cancelled. And 2 minus 1, 1 plus 10, 11. So the answer is equal to 11. I released some problems exactly like this for Stanford Math Tournament 2022. If you solve them, you could easily solve this problem. Problem number 15. Okay, before solving this problem, I should tell you two important things you should memorize and know about excenter and the angle bisectors. Okay, if we draw internal angle bisector of A, external of B, external angle bisector of C, then we call this one excenter, and it has proof why they are concurrent. This angle BIC is 90 plus A over 2, BIAC is 90 minus A over 2. And okay, as I said, there are around 50 important formulas you should learn. Let me tell you why it happens. This angle by exterior angle is A plus B. So we can say because it is half of that, it is A squared plus A over 2 plus B half, A half plus B half. It is A half. This angle is sum of this plus this. So it is A half plus B half, so it should be B half. Similarly, it should be C half. So B half plus C half is what? So we know if we add A over 2 and subtract A over 2, A plus B plus C is 180 over 290. 90 minus A over 2. I proved this one. Now, here you say it is internal angle bisector, external. It is half of this. Half of this, sum of them is 180. So if we add half of them, it will be 90. 90, 90, 90, 180. So this one plus this one should be 180. And it is 90 plus A over 2 because sum of them is 180. Now, let's solve this problem. This D is exactly this IA because it is external angle bisector. If you read triangle ABC showing diagram below, it explained the tangent from D to the omega of the triangle ABC. It's in circle. Okay, omega at E, this point, E and B are on the same side of line AD. Okay, if we draw this line is exactly AIA here. It passes also through I. So let me consider this is I, and it is not necessarily pass through this point. Okay, and it says what? It says BEC. So let me write it with pink. BEC is 112, then angle A is what? Okay, the relationship we can find is this is 90-degree perpendicular, it is perpendicular, perpendicular. So it is 90-degree. This one is 90-degree. And here, like, let me draw the rest of that with green. Internal and external are 90 degrees, so we try to create all 90 degree that we have. So it is also 90 degree, it is 90 degree. So for example, one thing that we can say, because it is 90, it's this side, ID. This and these two angles see same side and they are equal. So you can prove easily that there are 5 important rules for proving one quadrilateral is cyclic. One of them is equal angles see the same side. So because these, let me show these 4 points we can say are cyclic. And if we pass the circle through IAB, it passes through C also. This is 90, 90, some of them 180. So C lies on this circle, IE. So let me write I, E, B, I, A are collinear. Also because we know I, B, I, A, and C are collinear, and I, B, I, A, 3 common points, and from each 3 points that are not collinear, there exists only one circle that passes through them, circumcircle. So C also lies on that. Now we can say what? We can say this angle BEC equal to this angle, this one. And we said, okay, BIC is what? 90 plus A over 2. So 90 plus A over 2 equal to 112. If we multiply by 2, it will be 180 plus A equal to 224, and A equal this minus this this minus this, which equals 44. Okay, so we've reached the answer. And as I said, for example, two important formulas are these about orthic triangle length of them, angles of them, for perpendicular altitudes, for angle bisectors, internal, external. There are around 50 important formulas. If you know them, then you can easily solve these types of problem, and also from qualifying level for round 2 and up to IMO level. Problem number 16. Find the largest integer n such that n squared plus 5n minus 9 for 86 equal to 10 times s of n, where s of n is the product of all digits of n in the decimal representation of n. For example, s of this is this. Okay. So for example, when we have this one, I want to say for large n, left side will be greater, right side cannot be a great number. So I want to say s of n is at most what? If n is one digit number, for example, n is a, then we can say s of a is also a is equal to n. If n is ab, then let me write ab, then s of n is a times b, and n is what? Number ab, which is 10a plus b. Now, because here a multiplied by 10 and plus some positive, here a multiplied by b, and we know it is, this one is less than this one. Why? It is equivalent as 0 if you take it to right hand side and factor from a. 10 minus b plus b. A is positive, 10 minus b is positive, so it is strictly greater than 0. So after one digit numbers, you will understand. Also, if you check, for example, 3 digit, and easily you can prove for n. For when we have, for example, m digits. S of n, for example, it will be a, b, c, and L will be 1000a plus 100b plus c. Again, we say this is strictly greater than this, because if you take it to right side, it will be a times 1000 minus bc plus 100b plus c. It is greater than 0, because bc at most 81. It is strictly greater than 0. Now here we conclude what? We can say, okay, n squared plus 5n minus 9486 equal to 10 s of n. This one. It is less than, so look at the problem, says find largest integer n. Or we can also write less than or equal 10n. Not important. So n squared minus 5n minus 9486 greater, less than or equal 0. I've taken 10n to the left hand side, it will be negative 10n. Now, here we want to solve n is in what intervals? Okay, we don't need to find a specific answer here. If we replace, for example, n with 100, then here we have what? 10,000 minus 500. 10,000 minus 500 is 9,500. Minus this, it will be positive contradiction, and we know it is increasing for n greater than 5. So we understand that n is at most, because the problem says find maximum n. We found that n is maximum of n is 99. Okay, so for example, for this problem, if you check 99, it works. But let me tell you a better way. If you want to solve this one, we know, for example, for a small n, it doesn't work. For example, 1, it will be negative 2, negative, until we want to see what number it is negative. So we know it should be greater than 0, positive, because 10 s of n is positive. Also, you can say greater than equal to 10. Now, if you replace, for example, here 90, then it will be what? 90 squared plus 5 times 90. It will be this, it will be this number plus this. Now, we will see it is negative for 90, so we understand n is at least 91. Okay, so we understand that Sn we want to find is 9 times, for example, a digit here. We can say, for example, b, this number. So if we want to find this, if we consider mod 9, then n squared we have plus 5n mod 9 This one will be 0 because sum of the digit is 9 plus 12 plus 6, 18 plus 9, 27. It will be, this one will be 0, and right side, 10 s of n, it will be 0 because 9 times b is 0. So mod what? Mod 9. So we can say 9 divides n squared plus 5n. So we can say 9 divides n times n plus 5. So 9 divides n, or 9 divides n plus 5. So here, if 9 divides n between 91 to 99, 99 is the case. If 9 divides n plus 5, n will be 94. The problem says find the maximum. So we want to prove that 99 works. So 99 squared plus 5 times 99 minus 9486 equal to 10s of n times 9 times 9. Now, okay, we want to prove this. At first, we divide both sides by 9. It will be 11 times 99 plus 5 times 11, 55. If we divide by 9, minus 1, 0, 5, 4. We want to prove why it equal to 9. Okay, if we multiply this, it is equivalent that 1089 plus 55 minus 1054, why it equal to 90. This number minus this number, 9 minus 4, 5, 8 minus 5, 3, 35 plus 55. Here, it will be what? 80, 90, and it's satisfied, and it's the greatest number, so the answer of this problem equal to 99. Problem number 17, find the number of integer solutions to the equation this. Okay, when we have this, because we have x, y, and this, one important thing in number theory problems like this, consider this, it is so much useful. And from qualifying level up to IMO, y prime d, and their GCD is d, their GCD of x prime y prime is 1. Now I replace 19x prime d plus 93y, which is y prime d, equal 4xy. 4xy x prime y prime d squared. We know d is positive because it's GCD, always positive. If we divide both sides by d, 19x prime plus 93y prime equal to 4x prime y prime d. And here, we know x prime divides this, so x prime divide the only term that is left, 93y prime, because x prime, y prime are co-prime numbers, so x prime divide 93. And also you can say y prime similarly divide this and this, so y prime divide 19x. They are necessary conditions. So because y prime and x prime are relatively prime, so by using Euclid lemma, we can say y prime divides 19. So y prime can be plus minus 1 plus minus 19. So if we check, for example, one of them, y prime equal plus 1, case 1. Then if we replace here 19x prime plus 93 equal to 4x prime d. And now we can say 93, if we take these to right hand side and factor from x prime, 4d minus 19. Now, 93 is what? Is 3 times 31. If you check, this number is 3 mod 4. So let me check 4d minus this, is 1 mod 4, because if you add by 4 it will be 1 mod 4 if you divide, because negative 19 is 1 mod 4, 19 is 3 mod 4, and negative 19 is 1. So here it can only be 1, or, and we know d is at least 1, okay, 193, and also we can say it is equal to negative 3, because it can be integer, negative 31, all of them have this. So let's consider each case. The first case, d will be 5. When it is 1, it will be 93, x prime 93. For this case, d will be, we calculate 40 minus 19 is this, so 40 is 19 plus 93. So if you divide, d will be 28. And in this case, x prime is 1 for the second case. D will be 19 minus 3, 16. D will be 4, and x prime will be what? Negative 3 times negative 1, negative 31. In this case, D will be 19 plus this D will be negative, and that's a contradiction for this case. So let's find x and y for each of them. In this case, x is 93 times 5. And y will be what? Y prime is 1. We know it's y prime d. 1 times 5, 5. For this case, x is this times this 28. And y also will be 28. For this case, x will be negative 31 times 4. It will be negative 124. And negative 124. And y will be what? Y will be y prime d, which will be 4. And we have these three cases for this one. Now, the next one, we consider what? Case 2. Y prime equal to negative 1. Then we can say what? We can say, if we replace y prime with negative 1, 19x prime minus 93 equal to minus 4x prime d. And here, if we take this to left hand side and factor from x prime and take this to right hand side, x prime times 19 plus 4d equal to 93. And now, because it is 93, this one is what? 4k plus 3. So because it is 3 times 31, the only possible cases are 3, 31, 4k plus 3, negative 1, negative 93. And for each of them, the first one, it is at least 140, so it will be at least 23. So we can cancel this, cancel this, cancel this. So we only should check this. These GCD should be positive. So for this one, 4D is 31 minus 19, 12. D is what? D is 3. Because it is 31, x prime will be 3. So x prime is 3. So x is what? D times x prime, 9. And y is what? Negative 1 times d, which will be d is 3, will be negative 3. So we found one answer here, two answers, three answers, four answers so far. 19 and negative 19 is left. So case 3, y prime is negative, let's consider first 19. Our main equation is this, so we can say 19x prime plus 93y prime, which will be 19, equal to 4x prime 19d. And if we cancel both sides by 19, then we have x prime plus 93 equal to 4x prime d. Okay, and we can say 93, if we factor from x prime, 4d minus 1. Now, it is 3 times 31. So here it is 4k plus 3, the remainder. So it can be 3, 31, negative 1, negative 93. Because d is at least 1 positive, so these two cases are impossible. For this one, d is 1. Because it is 3, it will be 31, and also in this case, 31, 3. So d is 1. Now, we can say x prime is 31, so x is 3 times this 93, and y is 19 times 3. 19 times 1, sorry. D is 1. Okay. So y is 19, and also x is x prime d. Here d is 1. So x in this case is also what? 31. Okay. So for this case, d is what? 32 over 4, 8. So x is x prime d, 3 times 8, 24. And y is 19 times 8. Okay, we found two answers also here. So let's see how many answers have we found so far. 1, 2, 3, 4, 5, 6 answers we found so far. Now let's consider last case. Case 4, when y prime equal to negative 19, if we replace here, then we will have 19x prime plus 93 times minus 19 for x prime negative 19 times d. If we cancel 19 here, then we have x prime minus 93 equal to Here we can say negative 4x prime d. Okay, so if we take these to left side, these to right side, and factor from x prime, then we have 1 plus 4 d equal to 93. Now it is 3 times 31. So we can say what? It is, the remainder is 1. So you can check 1 here, 93, negative 3, and negative 31. So if we check 1, okay, if you check 1d will be 0. In this case, if you consider x equal to 0 on. So here it's impossible because y prime is 19. But at the first of the problem, because we've divided by d prime, all of them are in the case d is positive. We consider the GCD when both of them are not 0. So x0, y0 satisfy the equation. So we consider also this. So until here, 7. Now let's check 93. Because in this case, a GCD of x and y doesn't, we can say undefined. So here we calculate this, except this case, for example, 0 or other numbers, we can use GCD. The rest will be same. So 93, then 40 will equal to 92 and d equal to 23. So here we find another answer. It's 93, it will be 1. So x will be 23 and y will be negative 19 times 23. Another answer. So 6 answer, 1 answer here, 7 answer here. So we have 8 answers. So the number of answers equal to 8. So the answer of this problem is 8. Problem number 18. Find the number of integer solutions to the equation. This with x1 greater than equal, x2 greater than equal, x3 greater than equal 0. So exactly 2 days before the exam, I released a video, useful ideas for SMO 2022. In that, if you saw that video, it's so much useful for this problem. x1 plus x2 is 20 plus x3. So I check, for example, at first x3 equal to 0. So it will be 20, and x1 is greater than equal x2. So you can say it's 20, 0, and both of them greater than equal 0. And then 19, 1, you write until what? Until 10, 10. So how many numbers do we have? 11. If x3 is 1, then it will be 21, and both of them are greater than equal 1. So it can be what? 20 and 1, 19 and 2, 11 and 10. So how many do we have answers? 20 minus 10, 10. And the next one, if it is 2, then 22, we have 22 until 11, 11. How many answers do we have? 10. Now, if I copy, so if x3 is 3, then here, what can we say? 23. You can say 20 to 3, 2, 12, and 11, 23. So 20 minus 11 will be 9. And if you check also next one, so if we calculate, we have 11, and also it will be again 9. If it is 4, then 24, 2, 12, 12. If we calculate, it will be 9. And the last terms, you say 19 is 39. You can say 2019, one case, and if it is 20, 20, 20. So one case. So the answer is sum of all these cases. We have 11, then we have 10 plus 10, we have 9 plus 9, 2, we have 1 plus 1. So here we can say it is 11 plus 2 times 10 plus 9 to 1. And it will be 11 plus 2 times here. It is what? 10 times 11 over 2. You subtract, you factor from 11, it will be 1 plus 10. It will be 11, 11 squared, which equal to 1 to 1. It is considering some small example and find the pattern, not only pattern of the numbers, pattern of the solution. It is so much useful. Exactly 2 days before exam, I told you and I solved some problems, and I said that in SMO 2022, you will see same problems. Also for round 2, I will do the same. Problem number 19 in the diagram below, E is the point outside square ABCD. Okay, so it is A, and it's also A. such that C is parallel to DH to BD. These two lines, this one and this one, B equal to BD. So we know BD is what? A root 2. So B is also A root 2. Both of them equal to A root 2. B intersects CD at H. Okay, BD, CD, H. Given BE, we said BE is what? BE equal to BD equal A root 2. A root 2 equal to root 6 plus root 2. So if we divide both sides by root 2, it will be root 3 plus 1. Now the problem says find DH. Okay, so suppose it is X, for example, we want to find X. Because BE equal to BD. Okay, so let's write the angles we know. It's 45, it's 90. Before solving this problem, I should tell you ratio lemma. As I said, there are around 50 important ideas you should know. There are so much useful. 50 general ideas. One of them ratio lemma. Ratio lemma is this. For example, angle bisector theorem is a special case of that. So much useful. If P is an arbitrary point on BC, sine A1 over sine A2 is BP over PC times B over C. Okay, we want to use this. So we know it is 45. It is parallel to this line. So this angle should be also 45. Now we can say BE over sine 90 plus 45 is sine 135 equal to the next one is what? So because it's 45 90. Okay, so let's do something before that. I want to, because it is 135, we know BE is A root 2. And for example, if we consider this is alpha, if we use sine rule in triangle BEC, then let's see what we have. Sine alpha over A, this over this, equal to sine 135, 45 plus 90, over BE, which B equal to A root 2. And now we cancel these two things. Sine alpha, sine 135 equal to sine 45, some of them 180. Sine 45 is root 2 over 2. So root 2 over 2 over root 2. And we can say, write it like this, cancel, it will be 1 over 2. So alpha is here, alpha is between 0 and 90. So we understand alpha is 30 degrees. So I consider this one 30 degree. Now we know 30 plus 135, 165. So it will be 15. 180 minus 165. It is 45, it is 15, so it will be 30. Now I want to use ratio lemma because I know 30, 15, I want to find DH. I say what? I say sine, let's write like this. Sine, for example, 30 over sine 15 equal to DH over HC times this one, A over A root 2. And if we simplify, sine 30 is 1 over 2 sine 15. We can cancel these two. So it will be TH over HC root 2. If I multiply both sides by root 2, then root 2 multiply, 2 is root 2 times root 2. It will be root 2 sine 15 equal to DH over HC. Now, if I want to find sine 15, you can say sine 15 equal to sine 45 minus 30. Sine 45 root 2 over 2 times cos negative 30, it will be root 3 over 2, and then plus cos 45 root 2 over 2 times sine this will be negative 1 over 2. And if we factor from root 2 over 4, it will be root 3 minus 1. Okay, now, if we multiply root 2 by this, then we have what? If we replace sine 15 with this, root 2 times root 2, 2. 2 over 4 is 1 over 2, and you take 2 on the numerator, it will be 2 over root 3 minus 1 equal to dh over hc. If you replace sine 15 here with this, then you will reach this and simplify. Now I want to find dh, so I say dh over dh plus hc equal to 2 root 3 minus 1 plus 2 root 3 plus 1. dh over dh plus hc is what? Is a, and we know a is what? A is root 3 plus 1. So it will be dh over root 3 plus 1. Now, if we multiply both sides by root 3 plus 1, then we conclude dh is equal to 2. Okay, for solving this problem, we only use sine rule and ratio lemma. That useful ratio lemma is an idea. There are some also general ideas you can use. If you had any question about the 50 important ideas in geometry or all other things, feel free to send message to my WhatsApp number in the description and comments. Okay, problem number 20. For this problem, you should at first consider intuitive thinking to understand, and we want to solve it logically, not only a formula and then from formula reach something. We should know why it happens, and in each step we want to consider what should we do. So let's start. The diagram below shows the region or xy. Y is greater than equal this. Okay, so this diagram is y equal to half x squared. On the xy plane, bounded by the parabola y equal 1 half x squared. When it says y greater than equal this, it means this area. Okay. Let C1 be the largest circle line inside R. Here it means this one. And with its lowest point at the origin. Okay, so this is 0, 0. So here, this part, from here to here, it's a little hard to understand what does it mean. So we work on this. So let's read the following. Let's C2 be the largest circle lying inside R. Okay, so R and resting on top of C1. Okay, so it says find sum of radii of C1 and C2. Okay, so here we know it is, for example, this one, the largest one, we know this. Okay, but for this one, 0, 0, let's see it means what. So look, if I consider, for example, with pink, it is this, for example, if you draw, if you consider larger, but if it is larger than, for example, something, then it will be what? It will be something like this. And then look here, all of them are tangent to this line, to x-axis, but here look, it is on top of this pink circle. So the problem is what? This circle always is on top of y equal to 1 half x squared. So we understand this part, that it means what. It's important to at first know the problem is what, and then try to change it to mathematics formula. Then it's logically. But if the solution is not logical for some problem, it's not important to not solve that, because there are few students that can solve. So it's so much important to understand the problem. We want to solve all problems logically. So let's at first focus on this one. Let me draw. Okay, for this one, we consider, for example, it is R. This one is R prime, R prime, R prime. Okay, so at first we want to focus on this. If we write the equation of this, it will be y, or let's start x minus 0 squared plus y minus r squared equal to r squared. It will be x squared plus y minus r squared equal to r squared. Now here, look, we want to now apply this condition. We say, okay, we want to say it's on top of that. This one always should be on top of this one. So on top means what? Y of this should be greater than y of this one. Y of this is 1 over what? X squared. So we should find y of the circle. So y minus r squared equal to r squared minus x squared. So y minus r equal to plus minus root r squared minus x squared. So y equal to r plus minus r squared minus x squared. So the y of circle should always, for any x, the y coordinate of circle should be greater than equal y coordinate of the parabola here. So we can say what? We conclude r plus minus r squared minus x squared is greater than equal x squared over 2. Now, for each x, why we have plus minus? Because if you consider each x, we have 2y. Look, when you have a circle, for each x, because here we have origin, we have 2y. The minimum one, if the minimum one is greater than equal this, so this one is also okay. The minimum one, the down one, bottom one is what? Is minus sign. So it is r plus. This one is r minus. So r minus root r squared minus x squared should be greater than equal x squared over 2. Okay, here we can say what? We can say x can be, because the radius is r, between negative r and positive r, here is 0. So we can say x is between negative r and positive r, because we want to work on x squared is less than or equal r squared. Now, here we know it is equivalent that r minus x squared half is greater than equal r squared minus x squared. So if we raise, we should say it is positive. So look, if it is negative, then contradiction, because negative cannot be greater. So another condition is this one should be positive. So r is minus x squared over 2 is greater than equal 0. Now, if we raise both sides to the power of 2, we have r squared plus x to the power of 4 over 4 minus 2 times this will be rx squared greater than equal r squared minus x squared. If we cancel these two things and we divide by x squared, we can say x squared over 2 over 4 minus r is greater than equal negative 1. So look here, if x is 0, we can say it is okay. So we want to consider the case that x is not 0. Also, you can check here, if x is 0, r minus r is 0, and x is 0, it's okay. So x is positive, is non-zero. Now, also you can say only positive, because for negative sign you have also same things. So it is equivalent what? That x squared over 4 greater than equal r minus 1 for all x. So for a small x, it goes to 0. So it should, look here, if you say r, it is a constant. But this one x squared should be okay for all x here. So for all x near 0. So the only r that satisfies this condition, maximum r, the problem says. Maximum r is what? Equal to 1. Because, for example, if it is 2, then we have 1 here. If you consider x, for example, 1 over 100, then it will be near 0, and that's a contradiction. Okay, so now let's consider. Okay, now here we say it is 1, 1, it is r prime, so the coordinate, x coordinate is 0, y coordinate is r prime plus 2. So if I want to write the coordinate of this circle, it will be x squared, x minus 0 squared plus y minus r prime minus 2 squared equal to r prime squared. Now here, look, in this point, it's an important thing. When you have two functions that they are equal and also they are tangent to each other. So you can say the equations are equal. For example, suppose it is x0, it is f of x, it is g of x. Then you can say f of x is equal to g of x, and also f prime x equal to g prime x. Or you can define hx equal to fx minus gx, and then hx0 equal to 0, because f prime here, x0, they are equal, and you can say hx equals 0, hx0, and h prime x0 equals 0, because it will be f prime minus g prime, which equals 0. So we use these things. Here I write both equation because they are equal and also tangent to each other. So for circle, I write all of them near to each other. Y minus r prime minus 2 squared equal to r prime squared, and y equal to half x squared. So if they are equal to each other, we replace x squared here with 2y. So it will be 2y plus y minus r prime minus 2 squared equal to r prime squared. Now here we can say what? We can say if we expand, it will be 2y plus y squared plus r prime squared plus 4 minus 2y r prime minus 4y plus 4r prime equal to r prime squared. And if we cancel, then we have y squared, and for y we have this, and this. So plus y, 2 minus 4 negative 2 minus 2r prime, and 4 plus 4r prime equal to 0. Okay, as we said, they are tangent to each other, so if you differentiate, it will be 0. So if I differentiate, if you had any question about the solution of this problem or other problems, feel free to send message to my WhatsApp number in the description and comments. It will be 2y plus minus 2 minus 2r prime equal to 0. If we divide both sides by 2 and take these to right side, it will be y equal to 1 plus r prime. Okay. So we found this. Now we replace in the main equation here. Okay, now if I replace y is 1 plus r prime, so it will be 2 times this, plus it will be y is 1 plus r prime minus r prime minus 2 squared equals r prime squared. So it will be cancelled, this and this. 1 minus 2, negative 2. And negative 2 to the power of 2 is 1. So 1 plus 2 is 3. 3 plus 2r prime equals r prime squared. And now, if we take all things to right hand side, 0 equal r prime squared minus 2r prime minus 3, which equal r prime minus 3 r prime plus 1. So in this case, it's contradiction because r prime cannot be negative. Here r prime is negative 1. So we have only this. R prime equal to 3. So the problem says find the radius, sum of radius r plus r prime. R was 1 and r prime is 3. So 1 plus 3 is equal to 3. For coordinate geometry, there are some rules. For example, differentiation. As I said before the exam, I release useful ideas 2 days before the exam. In that case, I said differentiation is important. Derivatives, consider that Lagrange multiplier, and in senior, junior, I'm considering different cases. A small example in all sections, junior, senior, and open section, this year there were some problem, more than one problems in each exam that could be solved by that idea. In each problem I explained. Problem number 21. Find the smallest positive integer x such that 3x squared plus x equal to 4y squared plus y for some positive integer y. Okay, so because we want to solve this, we have 3x squared plus x and equal to 4y squared plus y. If we take y to left hand side, and then we have x minus y. We have 3x squared. If we take 3y squared to left hand side, then what is left? Y squared. Why I've done 3y squared? Because then the coefficients are equal. I can say this one is 3x squared minus y squared, which equal 3x minus y, x plus y, plus x minus y, equal to what? Y squared. Look, for each problem, we can solve it for example, general, but I want you to teach how we can solve with basic ideas with the things. Also, we can solve IMO problems with these ideas. Fine, considering a small example, because 2 days exactly before the exam, I released a video, and I said if you check small example, you can find the idea, not find the pattern of numbers. then it helps you. We want to solve exactly with the idea of the video I released 2 days before the exam. So 3y plus 1 equal to y squared. Okay, so here we know it is positive, this one, so it should be also positive. So x is greater than equal y plus 1. So if you want to solve this, for example, you can check some small example. We can say what? We can say if y equal to 1, then x minus 1, then 3x plus 4 equal to 1, and we see it is impossible because it is x is at least 1. So you can check some numbers and you can see many things. For example, one thing is what? The parity of this term, because sign is not important, and here 3. The parity of this term and this term is equal. So the parity of this term and this term is not equal. It means one of them is odd, one of them is even. Why? It is an important rule in congruency. For example, x minus y, because minus a mod 2 is a. So sign is not important. So x minus y is congruent to x plus y, and we can multiply by 3, because 3 and 2 are coprime numbers, mod 2. So here you can say one of them even, always one of them odd. Or the students don't know congruency, you can check different cases of x, y, odd, even, and you see one of them odd, even. So we can conclude one of them is odd, one of them even, so y squared is even. So we conclude y is even. So for example, when you want to check a small example, you will see, okay, when y is 1, a parity is not same. So for example, if x is odd, it is even. If x is even, it is even. 1 is impossible. So y is even, we only need to check y that are even numbers. Then we can say what? We can say, okay, so x minus y, we want, for example, for each y, we want the minimum x. The problem says find minimum x. So for example, if x equal to y plus 1, then what happens? So this will be 1. This will be what? 3x will be 3y plus 3, 3y. So it will be 6y. Or if I write 1 times 3x will be 3y plus 1 plus 3y plus 1 equal y squared. Now here it will be what? 3y, 3y, 6y plus 3 plus 1, 4 equal to y squared. And then we can say, okay, it is greater than 6y. So if you divide by y, y is greater than 6, but y divides this term, so y divides 4. Y is a positive and contradiction because a number greater than 6 is not a divisor of 4. So we reach contradiction for this case. Now, so we are checking, for example, x, y plus 1 to understand the idea of the problem. If x equal y plus 2, then what we have? Their difference will be 2, and then 3y plus 2 plus 3y plus 1, which equals y squared. Now, here we say what? It is 2 times 6y plus 6 plus 1, 7 equal y squared. And we can say it is greater than what? 2 times 6, okay, 12y. So we can say y is greater than 12. And now we can say what? We can say, okay, the right side we say y is even. So it is right side multiple of 4 because it is square. But on left side it is an odd number times 2. It is not multiple of 4. So if you consider mod 4, we've reached contradiction. For next one, if x equal y plus 3, then our main equation is what? 3 times 3y plus 3 plus 3y plus 1 equal y squared. And it will be 3y, 3y, 6y plus 9 plus 1, 10 equal y squared is greater than 18y. So y is greater than 18, and now we know y divides this. Y, it is what? 18y plus 30. You can check again divisibility, or you can say again right side is multiple of 4 and left side it is even. Okay, so maybe it's multiple of 4. Okay, here y divides this term, y divides 3 to 18y, so y divides 30. So the only divisor of 30 is y that's greater than 18. is y equal to 30. And if you replace y with 30, then it will be 3. 6 times 1, 180 plus then 190. And it is equal to 30 squared. The left side multiple of 19, the right side is not multiple of 19. Now, if we check x equal to y plus 4, then if we replace here, it will be 4 times 3y plus 4 plus 3y plus 1 equal to y squared. So here it will be 4, 3y, 3y, 6y plus 12 plus 1 plus 13 equal to y squared. So y divides 24y divides this, so y divides 4 times 13. And we can say it is greater than 24y. So if we divide by y is greater than 24. Y is even, so the only possible cases for y is when y equal greater than 24 and divisor of this. The only possible cases are 24 and 52. Because the problem says find minimum x. So at first we check 26. So if we check 26, then we have what? 4 times 6 times 26 plus 13. We want to check, is it possible? 26 squared. 26 squared is what? 2 times 13 squared. It is 4 times 13 squared. If we divide both sides by 4, then we will have what? We have these things. If we divide both sides by 13, then we have, it is what? 2 times 13. 6 times 2, 12 plus 1. Is it equal to 13? Yes, we see equal. So we found one answer. Y equal 26 and x equal 30. So we've checked until x equal to y plus 4. Now we say, okay, maybe for the other cases we can find minimum x. But if we check for the other case is x is at least y plus 5. Why? Because we said here it is positive. The problem says y and x are positive, positive, positive. It is positive. So x minus y is positive. We check this one for 1, 2, 3, and 4. So the other cases are it is greater than equal 5. So if x is greater than equal 5, then we can say here left hand side of this equation x minus 5, 1 is 5 times x is greater than, okay, so let's write greater than equal x with y plus 5 plus 3y plus 1. And we know left hand side equal right hand side equal y squared. So we can say y squared is greater than equal 5 times 3y plus 3y 6y plus 15 plus 1 16. So we can say what? We can say it is greater than 30y. So if we divide both sides by y is greater than 30. So x is greater than equal y plus 5. So x is greater than equal 35, or because we can say greater than equal y plus 5, and it is strictly greater than 30 plus 5, 35. So because the problem says find minimum x, we've proved that the minimum answer here is when x equal to 30. Okay, if you saw my video before the exam, I said considering small examples. For example, here we've considered it is 1, 2, 3. We found a very basic solutions. Also, it has other solutions for large numbers. But for this number, you should learn this. And this idea works up to IMO, international level. Again, for round 2 also, I will release some solutions, some ideas. You can use them to improve your problem solving. So keep in touch, and thanks for your support and for watching the video. Please don't forget to subscribe and turn on notifications. Problem number 22. A group of students participate in some sport activities among 60 different types of sports. It is known that for each sport activity there are exactly 100 students in the group. Okay, so look, for showing these things you can use graph 3, 4. We don't use some, for example, important rules in graph. We want to show them 1, 2, 3 to n. For example, here there are students And then you can also solve with tables. Tables and graphs are equivalent, but in graphs, for example, for harder problems, paths with length too, there are lots of things you can apply, but in table is harder. I saw many problems. I can say only one problem I saw in table you can solve, and in graph is harder. In 99%, the graph, if you work and solve some problems in graph, it will be so much easier. So let me show you. Here there are problems, the different types of sports on sports. Okay, 1, 2, 3, 4, 5, 6. Okay. And it says what? It says for each sport activity, there are exactly 100 students in the group participating in it. Okay, so if we connect, for example, if one student participates, for example, in one sport, we connect them, then the degree means the number of edge. Edge means what? The lines. The number of edge is 10, is 100. Okay, so look, we see all the properties in this figure. Now, the next one. And the union of all the sports activities participated by any two students, for example, 1 and 2, is not the entire set of 6 sport activities. It means what, for example, if 1 is connected to this one and 2 is connected to this one, then they have all activities. So it shouldn't happen. Now determine the minimum number of students in the group. Okay, so for solving problems that it says minimum or maximum, you should say answer is greater than equal, less than equal one number. So one part is with proof, one part with an example. The strategy is this. For also round 2 problem, this strategy works. So here, let's see. I say, for example, for 1, I want to consider some, for example, small examples of degree. Small example means from 6. So, for example, 1, from here, I consider maximum degree with delta. I show it with this. You can, it is only a variable, Greek letter. You can say A. So, maximum degree is delta. So, if delta is 6, then we have contradiction. Why? Because if it is connected to 6, so 1 with any, for example, 1 and 2, because 1 has all the sports, the union of 1 and 2 have all the sports, and here we have contradiction. Okay, so delta is not 6. If delta is 5, then we can say what? For example, 1 is connected without loss of generality, 1, 2, 3, 4, 5. So if any of 2 to n is connected to 6, we have problem. For example, if 4 is connected to 6, then 4 have 1. Their union have all 6 sport activities, and that's a contradiction. Why? Because 6 is connected to 100 here. So again, we have contradiction. So it is here. Now, if so, we have delta equal to 4 or delta equal less than or equal 3. Now, in this case, I want to tell you one basic thing in bipartite graph. Bipartite means 2 groups. When you have 2 groups, A and B, and you have some vertices here, for example, A1 to AK, and, or let me write, for example, 1 to K here, vertices 1 to K, or let's just write A1 to AK, and this one part B, B1 to, for example, BS. Degree here is D1, degree here is DK, degree here, for example, D prime 1, degree here, D prime S. This rule is so much important. Degree means the number of line that is connected. For example, here it is 100 for sports. D1 plus D2 plus DK, if you count them, it is equal to number of edges. Number of edges means number of lines between them. Only can we consider that all edges are between them. Equal to D prime 1 plus D prime 2 plus to D prime S. Okay, why? Because look, for example, as an example, if you have this and you connect like these things, then we say what here? The degree here is 2 plus 1. Why you say 2 plus 1? 1, 2, 1. Degree here is what? Let me write it with pink. 1 plus 1 plus 1. 1 plus 1 plus 1. So look, if you add this, you count the number of each edge from the top part. Here you count each edge from bottom vertex. So vertex are the points here. So they are equal the number of edges. Now here, I say, okay, the maximum degree is what? For example, if delta is less than or equal 3, maximum degree. So if I consider, for example, degree here, d1 to dn, I know d1 plus d2 plus to dn equal to what? 100, 100, the degrees here. 100 equal to 600. If delta is less than or equal to 3 maximum, so all of them are less than or equal to 3. 3 will be 3n. So if you divide both sides by 3, n is greater than or equal to 200. So for this part, I've proved that in this case, n is greater than or equal to 200. If delta equal to 4, then I can say what? So let's consider in delta equal to 4. Okay, for example, without loss of generality, suppose that one is, let me erase them. Okay, one is connected to 4 of them and 1 to 4. 1, 2, 3, 4. Okay, so we know that 2 to n, if you consider, they are not connected to both of 5 and 6, because if one student connected to 5 and 6, then for example 4 and 1 have all sports. So they don't have any common vertex, 5 and 6. So 5 is connected to some of them, and 6 is connected to the other one. They are not same. Here we have what? Here we have exactly 100, because 5 is connected to 100, the problem says. Here also sport number 6, 100. So n here is at least 100 plus 100 plus 1. It will be 201. So here we proved, if we consider all cases, it is n is at least 201. So by considering these cases, because if we consider all cases, the answer cannot be less than 200 because it is contradiction. It is contradiction. We have only these two cases. Here it is n at least 200. Here n is at least 201. So n cannot be less than 200. So here we said answer is greater than or equal to 200. It is with proof. Now we should focus on finding an example. An example that we have 200 students and all the conditions are satisfied. Okay, if I want to find n equals answer, look, sometimes proofs helps example, sometimes example helps. So, for example, for solving these types of problems, especially in round 2, work on both of them and try to reach same answer. The strategies for different problems are different. If you had any question about that, feel free to send message to my WhatsApp number in the description and comments. Now I want to prove we have an example with 200, then answer will be less than or equal to 200 because we found 200. The problem says n, find minimum n. So the answer will be 200. Now let's find an example. So here we said, okay, if delta equal at most 3, then if we check our proof, if we want to reach 200, equality here. So d1 to dn should be 3, all 3. So we should connect these to 3 of them, these to 3 of them, these to 3 of them. We want that they have a good pattern. And also we should pay attention. For example, if one of them connected to 1 to 3, the other one cannot be connected to 4, 5, 6, because then, for example, if it is connected to this, it is connected to this, then their union will be all of them and it's contradiction. So here we understand all of them should be connected to 3 of them. We want to gradually reach the solution. So 1 is connected to 1, 2, 3, for example. The next one, we can say 1, 4, 5. Next one, for example, you can say 2, 4, 6. And we have 2 1s, 2 2s, 2 4s. Okay, 3, 5, 6. If you write 3, 5, 6, you've selected from each of them twice. So it is the first part. Again, you repeat it for second one and for third one to 50. Why? Because you should see 100. And in each box, we see, let me call each box. For example, it is what? It is 1 is connected to 1, 2, 3. 2 is connected to what? 1, 4, 5. And like this. So if you consider these 4 vertex 1 to 4, then we have this. So each vertices come twice because we want 100. So 1, 2 to 50. And The number of vertices will be, it is vertex 1 is connected, vertex 2 is connected, vertex 3 connected, vertex 4 connected here, these vertices. And these things, 1, 2, 3, there are these sports. Okay, 1, 4, 5, these. Okay, so then for each box contains 2 pink vertices here, and it is vertex 1 of this part. Student 1, student 2, student 3, student 4. And the last one, 50 times 50 boxes, 50 times 4, which equal to 200. If you had any question, paths with links to also is important. Idea and combinator is also like geometry. There are some ideas we can solve basic level. For example, Hong Kong 2022 round 1 with path with length to also IMO problem. Also AMC problem for America and for other parts UK. If you had any question to work with graph, for example, solve problems, know the ideas of graph, feel free to send message to my WhatsApp number in the description and comments. Problem number 23. It says let P and Q be positive integers such that we have this equation, determine the smallest value of P. Again and again, we want to use considering a small example, which I mentioned that in my video, in my channel, exactly 2 days before the exam. I said what? I said Lagrange multiplier, and I said it's useful to use that in the exam. And in open section senior, you should use that, and you could solve many problems with considering a small example. Problem number 21, hard problems of this exam. So here we have what? This expression, it says find the smallest value of P. Okay, so we can say, because we can factor from P, let's factorize 5P minus 18. Right side is Q. Q to the power of 8 minus 7. So here, we know right side is positive, so also left side should be positive. Now, if we want to, left side is positive, so you can say it is increasing. So if you want to find minimum of P, it is equivalent to find minimum of Q, exactly like problem 21. For finding minimum X, we've tried to find minimum Y, and X minus Y, for example, was greater than 5. If you see my solution for problem number 21. So here, we try to check some example to understand problem is what. So at first, let's try when Q equals 2. So P times P squared minus 5P minus 18 equal 2 times 28 minus 7. It is what? 28 is 256. And it will be 256 minus 7, which will be 249. And we can factorize 2 times 3 times 80. 383 is prime. Now, here, P can be only what numbers? 2, 3, 83. 2 is impossible because this one will be negative. 3, 9 minus 15, again it will be negative. Also, if you place 83, then you can say, okay, it is 83, factor from 83, 83 minus 578 minus 18. It is so much greater than 6. So Q2 contradiction. Let's check Q3. Also, I released some problems of IMO international level in my channel. Also for 2021-2020, you could solve them completely with considering small examples. So let's solve the next case. P times P squared minus 5P minus 18 equal to 3 times 3 to the power of 8 minus 7. Now, if we calculate that, 3 to the power of 8, 3 to the power of 6 is 7 to 9. It will be times 9. So it will be 9, 9, 81. 9 times 2, 18. 16, 26. And then we have 9 times 7, 63. And it will be 61 minus 7. It will be 3 times 11 minus this 4, 5, 5, 6. If we prime factorize this number, it will be 3 times this one. It will be 2 times 29 times 113. Okay, now we want to find what P is good. P can be only, let me write possible cases. P can only be 2, 3, 29, 113. If you place 2 and 3, it's obvious here it will be negative. For 113 here, it will be a large number greater than this like previous time. So we will check 29. So here it will be what? 29 times 29 squared is 841 minus 5 times 29. It will be 45. We have 4, 145. 145 minus 18. Okay, here if we add, it will be minus 361. If we subtract 11 minus 3, 8. It will be 3, 13 minus 6, 7. And 7 minus 1, 6. So if we factorize this number, it will be 2 times 3, 3, 9. And it will be, if I continue, it will be 2 times 3 times 1, 1, 3. Exactly here. So it works. We found for Q3 P equal to 29, and it is the minimum answer because we said if you increase Q, P should also will be increased, and we can say the minimum answer here is 29. So again, we've solved this problem with considering a small example. You can solve so much harder problems with that idea, like IMO problems, and you can see them on my video. And exactly 2 days before exam, I told you this idea is so much useful. Again, I will release useful and important ideas for next rounds and other Olympiads. You can use them. And so please don't forget to subscribe and turn on notification for having next ideas. Problem number 24, given that a, b, c are positive real numbers such that a plus b plus c equal to 9, find the maximum value of this. Okay, we want to use AMGM. We say a over 2 plus a over 2 because we want to create a squared plus b over 3 plus b over 3 plus b over 3. Why I write this? Because I want to also use this plus. C over 4 plus C over 4, 4, C over 4s. Over what? How many numbers I've written? 2, 3, 5 plus 4, 9, greater than equal. Ninth root of a over 2 squared, b over 3 cubed, c over 4 to the power of 4. So here it will be what? A over 2, A over 2, A, B, this one B, this one C, 9 over 9, which equal to 1. So we can say what? If you raise both sides to the power of 9, then we can say what? I write 1 is less than or equal A squared, B cubed, C to the power of 4, 2 squared plus 3 times 3 cubed times 4 to the power of 4. So if I consider this one t will be less than 2 squared times 3 cubed times 4 to the power of 4. If we calculate left side, it will be 27, 6, 4, 8. Now we should prove that it's impossible to reach this. We know equality happens when all terms are equal. A over 2 should be equal to B over 3, should be equal to C over 4. And if we consider A equal to 2, B equal to 3, C equal to 4, then all of them will be 1. And also 2 plus 3, 5 plus 4, 9. It satisfies this. So also we prove in this case t equal to 27, 6, 4, 8, because in AMGM here, AMGM that we've used, equality happens when all terms are equal, and we could use that because all the ABC were positive real numbers. 25, let R plus be the set of all positive real numbers. Let f from R plus positive real numbers to positive real numbers be a function satisfying x by f of x times f of y minus f of y f of x equal 1 for all x, y that are positive real numbers. Find f of 1 over 20, 22. For solving these types of problems, like BMO problem, I released BMO round 2 for UK, British Mathematical Olympiad. I told you in that video some important things about functions. One of them, let me write some important rules for function problems that are useful from qualifying level up to IF. Okay, I've written around 6 important, there are around 15 important rules you should use. Considering small example and special cases, I told you in my previous video exactly 2 days before the exam, get rid of complicated term. For example, here, this term is complicated. We should try to find two things that this term is equal and then subtract to get rid of that. Switch x, y, sometimes you need to change. Injective, surjective, check is it one-to-one or surjective. Telescoping rule in IMO problems also useful. And some around, I think, 9 or 10 important other rules. So let's start here. At first, I have a complicated term. I want to get rid of that. So let me write it again. Okay, because I want to get rid of this. If I, for example, switch x and y, then they are not equal. But if I replace, because it is y, it is f of x. You can't change f of x to x, but you can change y to f of y. If we replace y with f of y, then we have what? X f of y, f of x times, let's expand. It will be what? F of y minus x f of y, f of x times, okay, now we have much space. X f of y, f of x minus f of y, f of x equal to 1. Now, let me paste it in other place so that we have more space. Okay, now we want to get rid of this complicated term. Oh, sorry, here we have product x f of x times this times minus this. Okay, so let me correct. Okay, now if we switch, it's good. Why? Because if you switch x and y, then you have equal term, and then like two equation, two variable, you multiply this by corresponding coefficient to get rid of this. So if we switch x and y, then we have what? Y. So look, at first we know general solution, and then we write specific things. That's so much useful for especially hard problems. Here, change x and y, it will be f of x minus, this one is what? Y, f of x, f of y, f of x, f of y equal to 1. Now, if we consider these two equations and we want to get rid of that, these things is equal. So, if I multiply the first one by y, like two equation, two variables, and this one by x, and then subtract, let's see what we have. The first one, if I write rest with blue, the first one will be yx, f of y, f of x, f of y. Now here, you multiply this by y, xy, and x here, and subtract, so it will be cancelled, so you can write only minus x times this, minus xy, f of x, f of y, f of x equal to what? Right side. It will be y minus x. Now here, if we factorize, we have what equal terms? We have yx here, f of x, f of y, f of x, f of y, so we can write xy, f of x, f of y, and then here f of y minus f of x equal y minus x. So we get rid of that complicated term. Now we try to also get rid of this with replacement f of y. Okay, so we need what always when you want to solve these kinds of problems, it's so much useful. Work a little on sentence what you want to solve. Work a little on assumption. So here we try to find f of something. So if we consider y equals 1, here. Then I have f of x. So it will be what? X f of x times f of 1 minus f of x equal to 1, and that's so much good. Why? Let me draw this also. So much good. Why? Because we can find f of x with only f of x and f of 1. So if we divide both sides, because the problem says x and f of x are positive integer, we divide both sides by x f of x, and now we can say if we take it to this side or multiply by -1 and take it to right side, f of x will be what? It will be negative, take it to right side, f of 1 minus 1 over x f of x. Okay, now it's the time to replace here. Also, replacement in algebraic problems are so much useful. You can solve hard problems with that simple idea. So x, y, this, now I replace f of 1 minus 1 over x f of x. So our goal to solve problems with logical ways. Okay, so minus f of, so here it is f of y. We should write y. And then minus f of x. It will be what? Minus f of 1 minus 1 over x f of x. And it will be what? Y minus x. So f of 1 and f of 1 will be cancelled. If we expand this, xy times this will be what? It will be minus y f of y will be cancelled, minus x f of x. And okay, if you multiply this by this, minus minus plus, x f of x will be cancelled. It will be plus y f of y equal to y minus x. Now we take similar terms to one side. So for example, left side will be y f of y minus y equal to x f of x minus x. So we can say it is correct for all x's. So it is constant. We can consider this constant c. So we say x f of x minus x equal to c, and we can say x f of x equal to what? C plus x. And then we divide both sides by x because x is positive real numbers. The problem says it is not 0. You can divide c over x plus 1. Now we want to find c. If we find c, then the problem will be solved completely. Again, we should use replacement in main equality. So in main equality, if I replace x equals, look, special case, x equal to 1, y equal to 1, then I have f of 1 times f of 1. Okay, so minus f of 1, f of 1. If I consider that, I want to see we will have what? So f of 1 is what? Most of the time we can replace x with 0 here because x can only be positive real numbers. I consider a special case, the simplest one, c plus 1. So if I replace here, f of 1 is c plus 1, f of 1 is c plus 1, f of 1 here is c plus 1, and now it is x. If you consider this x, minus, it is what? C over x here. X here is c plus 1. C plus 1 plus 1 for this 1. Now we want to find what? We want to find c. So here we can say this one, -1 will be cancelled. If we expand, it will be c squared plus c minus c plus 1 times this minus c equal 1. We can cancel these two terms. C squared is 1. C can be positive -1. If for f of 1, if c is -1, -1 plus 1 is 0. So c can only be 1, and if I replace f of x was c over x plus 1 will be 1 over x plus 1. The problem wants to find f of this. It will be 2022 plus 1, which equals 2023. Okay, as you can see also in this problem, we've used, considering small example, special cases, but also, we've used Lagrange multiplier. I only released one video before the exam. I tried to consider some ideas like Lagrange multiplier. Considering a small example, I've solved some sample problems. I told you also in 2022 you need them, and as you saw, we've solved many problems with small examples and logical way. That's so much important. We've solved completely. These things are important because we want to use this idea for also IMO problems. And round 2, in that level, these things are so much helpful. And also for next round and also other Olympiads, I will again release another useful ideas. You can use them. For example, for function, I told you here 6 important ideas. There are 9 other ideas. Also, there are so much useful. If you want to know the ideas, lessons are in the books, teacher says, but ideas are important. If you solve many problems, then you will see some common ideas and general ideas. General ideas are so much useful, and solving a problem with logical way also is so much important, because some tricky ways maybe in the exam it doesn't come to your mind and you can't solve problem. But if you think logically, I tried to solve all problems of junior, senior, and open section, all of them with only logical ways, step by step check the from the problem from different aspects. So if you had any question about the solutions of the problems in this exam or other exam, feel free to send message to my WhatsApp number in the description and comments. Thanks for watching my videos and for your support. Please don't forget to subscribe and turn on notification for having next videos.